I just do this stuff when Paul's here, so Paul can tell me when I'm being stupid and fix it for me. Okay. Paul, it says it's working, but it's not working. Like I'm doing a hangout on the air.
First problem is it's a Mac.
Oh, there it goes. Oh, nice, Paul.
Okay, just say because it was a Mac. Yeah.
Yeah. He's just going straight for the jugular on that one.
What's working now?
Yeah, it's recording, so I'm good with it. Am I audible for Lightbox making fun of me? Okay. So Ray asked me to start with something here. Ignore the fact that it says a conference. It's not that conference, but so I have exceeded the capabilities of Keynote with this presentation. I have so many GIFs in it that I've actually broken Keynote. So I have to be careful what I save and not save. They're not like cat GIFs, they're actual like big animations. But anyway, Ray asked me to add this slide in. We do have a community Slack here. A lot of us are on it a fair portion of the time. Sometimes it's active, sometimes it's not. Usually some good discussions happening in the different rooms. We keep it somewhat separated, but we tend to blend everything in together eventually. So anyway, just come find me. I can give you the sign up form on my computer. You just type in your email address, it'll let you in, and then you get an invite, click the link, and you can choose all your stuff. Okay, so getting started. Everything in this talk involves functions. And this is like in the sense of a mathematical function, where you normally see like something like this notation, or if you remember your algebra textbooks, it probably looked a lot like this. The top would be more of like a formal function. The bottom would be more of like, this is an anonymous function as far as math goes. But the idea is you pass an argument to the function, which would be x there. And we can say that the function is x times 2. So any x you pass into that function is going to be the value you get back. So if you have used PHP in the past, this is the exact same thing we saw on the last slide, but in PHP syntax. So function double x, we can give it the name double, or we can leave it nameless. I added the JavaScript slide. I will not be saving it to Keynote or it'll explode. So the JavaScript slide here. Top one is a named function, looks pretty close to PHP. The bottom one is using the new Lambda syntax in ECMA 6 2015 it started. It's been available for a while now. And this is how those two things look at Elm. There's just a lot less syntax involved. So Elm is a purely functional programming language. We'll get to what that means in a minute. It is browser-based. It compiles to JavaScript. And it's from the ML family, which is like standard ML, Haskell, OCaml. They all kind of look fairly similar. So please do not abandon the presentation because you're going to see some syntax that doesn't look normal. One of our guys next door was like, nah, I can't do the syntax, so he won't come over. But it's Dave's employee. But Elm is like Haskell on easy mode, so you don't have to understand category theory and all the other high-level academic concepts to get running with it. But the basic premise is that if you use Elm, you get no runtime errors. So if you've had undefined is not a function or null does not have method blah, that stuff doesn't happen anymore. And for me, that's refreshing because I make tons of those and my bug snag is filled up with them. So probably should have checked the live feed to make sure the audio is actually working, but whatever. So the functions Elm, we'll go back to here. The idea is that the function name is the first thing you see, double. Then there's a space followed by the argument list. And all of the arguments will be separated by spaces. And the idea behind that is that because functions are the low-level primitive of ML family language, they require the least amount of syntax to use. So Eric Meyer kind of explained this in one of his videos where in mathematics, multiplication is used very often. So if you have like 2 next to another number in parentheses, that implies multiplication. In this case, if you see a space, there's like an argument thing declared with a function. So like function f, and then you can do x, y, z as the arguments. So let's take a look at something a little bit like slightly more complicated. This is a function that takes 2 arguments, name and message, and it just concatenates the strings together. So there's not a whole lot complex there, so let's go ahead and paste it into a REPL. And when we do that, we get this gibberish back. And then when we type it in with the parameters that we assume it's using, we get hello to Bob. The gibberish we saw on the screen is the type annotation for this function. Elm will infer the type for you. You don't always have to type it out. And it's pretty good. You normally don't need an annotation. I tend to prefer to write them just so I know what it expects. But in this case, this syntax probably looks a little funny. So what it's saying is the function message2 takes a string, it takes another string, and then it will return a string. And those are all just connected by arrows. So I guess this is just going to look a little funny until a few more things get explained. But just trust that whatever the last argument is what gets returned. Or not the last argument, the last word of the arrows is what gets returned. So Elm is statically typed. And that's part of the reason we care about those type annotations. The compiler is actually going to tell us whether we get things right or wrong. And again, Elm is a purely functional language. And that means that the functions have no side effects. And this is just like in math. If you perform some sort of function in math, it's not going to turn on your lights at your house. It's not going to make a call to the database. Elm's not going to do that stuff either. You cannot control things from outside of the function. And the typical response you get back from a lot of the people who haven't used a language like that is, well, how do you do anything useful if you have no side effects? The idea is that you don't. The runtime will do the work for you. You can give Elm instructions to perform on your behalf. So you can say, I'm going to return this task that I want you to do that updates the database. And it could do that if it had a database. So Elm is statically typed, it's pure. And going back to the function annotations, every function technically only takes 1 argument. Elm will just give you that syntactic sugar to look like the rest of the programming language that you're familiar with, and it will curry them together. So we'll take a look at some of that in a little bit. I probably should have pressed arrow key over for those. And the other nice thing about it, if you use something like Ruby or any Lisp, the last value is implicitly returned. The same thing goes for Elm in this case. So to kind of demonstrate what I was showing, if you pass 1 argument to message2, it gives you back another function. And that function takes 1 string and then returns a string. And we can actually save this value off into its own new function. So now we have this new function, message to Bob, that we can use. So if we call message to Bob, and then pass in hi, I thought I was going to use hello there, but pass in hi, I've got the value hi to Bob back, and that's a string. The equivalent code in JavaScript would look something like this, where I declare a function, I assign that to message2. Function has a first argument, name, which we're going to call required, and then the message is going to be optional, and we'll say there's an empty string. Technically, you don't even have to do that, but for the sake of demonstrating it, message is there. So the message function takes a message, and then it concatenates message to name, just like the other one. At the bottom, we say, if there's a message, I want you to call that function I just declared. Otherwise, return the function so I can call it from the command line or wherever I'm using it from. This is the same thing in PHP. So this function can potentially return a higher order function. This is gobbledygook that I swear looked more relatable if you're a PHP developer. So if you've done PHP, this should look pretty familiar. But this is how the function works in PHP. So this is just kind of prove I'm not a liar. So we'll just skip the rest of it. But functions are first class. Is everybody familiar with what a first class function is? For reals, I'm looking for hands. No? Okay. Have you used jQuery? Yeah. Okay. So every time you call like jQuery, here's a selector dot, like a click handler, you're passing in a function to that, that function in click or on. That's all a first-class function is. It's a fancy name for it, but it just means that a function can be an assigned variable. So the things that we were doing, that's all it is. So we're going to look at a quick example. This is how to map over a list. So if you've done C or C#, you've definitely iterated over things with for loops or while loops where you have to keep a counter variable and set an upper limit of that. Say like if I is less than 10, iterate I++. In this case, we just say, I have this list of 10 elements, and I want you to apply this function to each element in the list. The guarantee from that is just like in math, you get a return list of the same number of elements that you passed in, but they're going to have some transformation given to them. So in PHP, there's an array map function, and you can do this stuff in PHP. It all works. If I pass in the list 1, 2, 3, 4, 5, which is the second argument, and I pass in the function element times 2, we get that double list right below it. In Elm, it would just look like this. You would say list.map, and just for the clarification there, list is not a class. It's not an object. It's just a module, and you would access a function inside of that module by the dot syntax. So we're saying map over the list 1, 2, 3, 4, 5 with this anonymous function. And in Elm, you declare the start of an anonymous function with the / there. Does that make sense for everyone? General concept there? Yeah.
The elm-make language, you put that arrow in there as well to like that goes with the function.
Mm-hmm.
Right now, in second, the arrow.
Yeah, the arrow is like the divider between the argument list and the function body. So if I go back to this one, in JavaScript, it would look like that, the fat arrow that's there. It's that same concept. So this is the divider. Yeah.
So you would use that same like space argument separation when you're declaring an anonymous function too, like if you want to pass arguments in.
Right. Okay. Yeah, it's the same thing. It's just instead of an equal operator, you put that little fat arrow in there, or I guess in Elm it's the skinny arrow. So in PHP, if we wanted to do it by naming an anonymous function, which when you say it out loud, it sounds kind of stupid because then it's not anonymous, right? But you're saying that this function, which I haven't given it a name, store it inside this variable. Then you can pass that variable into array map, and it still works exactly the same as how it did on the last slide. Elm does the same concept here. Double equals anonymous function, and then you can pass in double. So with Elm doesn't care how you name the function. It just wants, like an anonymous function is equivalent to what you just saw here. So double equals anonymous function, it transforms into that syntax at the bottom. That's how you declare a normal function in Elm. It is exactly the same as far as the compiler is concerned. So if you try this in PHP, PHP doesn't have the same concept. You have to move a closure into a variable like it is above. You can't declare a new function like array map there and pass it into array map itself. You technically can if you make it a string, but I've always found that to be extremely sloppy, so it's just not something I do in production. So the example I gave is a GitHub issue viewer. We're going to enter a GitHub repository name in. It's going to do an HTTP request and give us the issues back. And the things that we're going to show from that JSON payload, each issue is going to come back with a ton of information. We don't really care about most of it. We're just going to show the title of it, the body, the URL, how many comments are on there, and then the different labels that are applied. Things like bug or won't fix or enhancement. Those are probably the standard ones. So to get started with Elm, you just make a new directory. We'll call it issues, and then you cd into it. Then from there, we can, this is assuming you have Elm installed already. So you can run elm package install, and you ask for the HTML package. And the compiler and the package system are both extremely polite, and they're nice to you. They don't scream at you as much as like C++ will. Or the frustrating ones when you get a seg fault and doesn't tell you anything because you're outside a compiler then. This one's very polite. It says, here's the upgrade plan. Do you approve of these things? So it won't just go and install dependencies without your confirmation. So say, yes, you're very polite. Thank you. I would love for you to do that. And that little transition there, I did not edit that at all. That's how fast the package repository is. It's not super huge. It's definitely not NPM size. So things come down very quickly. So if we're in the issues directory, I'm just going to create, go back there just for the purposes of it. That's not that important. I use the touch command to create a main.elm.
Is that a half-life symbol at the beginning of your terminal?
They use it in Half-Life, but it's a lambda.
Oh.
So, that's probably something else I should mention. Anytime I say lambda, closure, or anonymous function, you can assume for these purposes they are the same thing. There's technically differences between closures and anonymous functions, but it's kind of whatever. So then I'm going to copy this pre-made example. I've already made an HTML file behind the scenes. I copy it in. And we're going to use this as our template. And this is everything inside of the directory as we've started. When we ran the elm install, or elm package install, it created that elm package.json file for us. That directory that says elm stuff is where it shoves all of the packages and meta information about them. Index.html is just the thing I copied in, and main.elm is probably where we're spending the rest of the time. And you can think of the elm package.json to be the same thing as like package.json or composer.json, all those. So I don't know if any of you guys have ever seen my screencast or just hear me talk about things in general, but I'm a very big Vim user. Technically, I use Emacs these days with Vim inside of it. And like one of the accidental things that happened when I had a baby is that I named her with the initials Vim. So it was coincidental my wife actually noticed it, so I'm super proud of her for that. But we're going to use Atom because the Elm integration works out a little bit better. And like I know this is a little hard to see, but a lot of it's not super important. I just want you to see how things pop up, and I'll explain like the key details of it. So this is.
You want to pull the shades down? Private users.
Oh, I didn't even know there's silicon. Yeah, could you? Thank you. Oh yeah. Okay, so this is that main.elm file. It's just blank, and you can see that I'm already getting a warning. And Elm can't find anything in here. It's looking for an entry point in where, like, Elm is kind of like C, where you need a main function to start the program. You need it to kick off something. So it's looking for something to work with. So we're just going to give it something, and we're going to tell main to return hello world. We'll see what happens. So if I save it, this just magically pops up for me. It detects that I'm trying to use a file, and it's main. So it's going to say, okay, I'm going to create this module for you. This is now a module named main, and the exposing ... just means every function or thing that I declare inside of here will get exposed to the real world if they want to do it. So if somebody calls main.main, it would be this function. And then you get like some notices down at the bottom there. So two things happen. One, elm-format ran. This is a plugin that you can get. It's just an extra package, and it will run all the code in your file through it, and it will format it for you. So if you are not keen on like worrying about where to indent your code, don't worry about it. Elm will just fix it for you. The second thing that happened, sorry, I covered this earlier. The second thing that happened was elm-make ran, and this is the Elm compiler. What it does is analyze the code. Then it saw the unsupported type return from main. It expects something very specific, and then it gave us some suggestions. So this is what it told us. It said the main value has an unsupported type. I need one of these things to render on the screen, and you gave me a string. And you know, compilers, you're like, yeah, you son of a bitch. But it's actually, it's super helpful if you just read it. So granted, when I did C++ work, I was like 18 to 22. So I was not super experienced at it, but I swear that thing was not super helpful. I use C++ or G++, so it's part of GCC. Clang seemed a little bit better when I worked with it, but I still hated those compiler messages. This one tells me exactly what I need, and that's fantastic. So it says, I need HTML, SVG, or a program. We don't need to care about what SVG or program are right now, so let's return some HTML. So I'll come down here, we'll import the HTML file, the HTML module, and I'm just going to expose everything because why not? It's going to be used commonly. So I'm going to create a text node. And that got rid of our compiler error. So that means that this thing is now usable. The warning that we get is that I inferred the type notation. Now we'll just zoom in here. So I inferred the type annotation so you can copy it into your code. That's pretty awesome. So you literally just copy and paste, and you can have it in your code. So you can see it. All right, so every time there's like a hang like that, and it seems like I'm just like lost, that's the part of Keynote that's broken. These GIFs are so large that it hangs while it's trying to figure out what to do. It's very interesting. I don't recommend doing it this way. So what is HTML message? That is, it's like a chunk of HTML can return a value of type message. For right now, you can pretty much just ignore it. It's not super important, but we'll get a little bit more involved later. So for development purposes, using elm-live is the easiest way to get going. It's like a pre-built development server, and it has live reload baked in. So if we kick off elm-live and we point it to main.elm, and we're just going to type in output equals test.html, gives us all this information, says successfully built, and it's loaded on port 8000. So if we load it up in the browser, it's working. But if you remember earlier, I told you that Elm compiles to JavaScript, and it just compiled to HTML. So the thing about Elm is it gives you some extra benefits baked in, and it knows that it's a language that's built into the runtime. So he's baked in a few extra things that will just make life easier for you. So if you want to test out an Elm file, it'll just bake in the HTML that's needed to load it up in a full screen, and then let it go. But for real life purposes, you're going to want to compile to JavaScript. This is really all you need. These lines in this block will get an Elm application loaded into your code. So you need an element to inject the application itself into. You need the Elm source code that got compiled, and then you just embed the Elm app into that element at the bottom. So this is the index.html page, and this is what we're going to be creating. Let's go ahead and start moving it over to Elm. I have 3 main parts here, and ignore the title, right? So this is the chunk that we're going to fix up. We have the search bar, the place where we have a text input and a button that we would click. We have a list of issues, and the list is comprised of however elements we have. So let's start off with the top one. So we're going to jump in here. We're going to grab the form code, and we'll just cut it out of the file. And we can come in here, and we're going to need certain things in HTML that the HTML package doesn't give us. Things like class, placeholder, the type, the value, style, href, things like that. So we'll grab it from the HTML attributes model. And these are being brought in as unqualified imports. It's kind of a fancy term of saying instead of having to type out the full module name and then .class, we can type out class and placeholder. That's how we're able to use text freely in this area. So we're just going to say that main returns the input view, and the input view is another thing of HTML. And then this is what it looks like pasted in plain. This is the HTML as it looks now. And when you convert it to Elm, to me, this doesn't look much different. So you go from this to this. Roughly the same number of lines, elm format, adds a couple here and there, but that's the gist of it. So you can still see things that look very familiar. There's the form with the class form. Instead of an equals, you have the space between them because now class is technically a function. You have nested divs inside of it. There's the input with its type. The underscore is just there because type is a reserved word in Elm, so you need to call it something else, and that's the shortest thing they got. So every HTML element, with the exception of the text node, returns a signature like this. It takes a list of HTML attributes, so just think of it as square brackets or an array in JavaScript. Then it takes a list of HTML nodes. So if you want to make things like the hierarchy that we saw there, you just keep putting new nodes inside of it. And all of this just returns the HTML message. So the things highlighted in blue there, those are the different components, the name and the two lists. For something like a text input, which wouldn't really have any children nodes, you just pass it an empty list. That way everything stays uniform and it makes sense. So let's jump up and do another one. We're going to start with a list. And we don't really need to take care of like duplicate code. So all the children nodes in here, I'm just going to delete those. And we're going to grab out one of the children. So we're pretty much left with nothing in this file now, and that's pretty awesome. Oh, come on, Keynote. I got the beach ball of death. There we go. So we'll call this one issues view. And this is the entire list here. Give it a type annotation, paste it in. And technically there are some plugins in here that you can use where if you just highlight the text and say convert to Elm, it'll do it for you. But because I have this on a screencast presentation thing, you don't have to worry about it at all. I'll just snap my fingers and make it work. But here we're dividing it into the two sections. There's the list view, which is effectively just a div that's going to contain other things. And then the single issue view, which will contain all the rest of the HTML for the chunks themselves. So this is easy to convert. So does that make sense to everybody, what it's doing there?
Why do you have the issues you have in your class?
So when I say I have a list of issue view, that means that I can put X number of issue view functions in there, or X number of issue view values, and it will make those like children nodes. Yeah, that's the big thing, and I probably should have reiterated that a few times in here. Everything that you're looking at right now is either a function, a list, or a string. There's no magic here. There's like nothing crazy happening. Try not to think of it as anything beyond being functions and passing things into functions. So there's the issue view converted. We don't really need to worry about it because it's all basic. So when we refresh the view, nothing showed up. That's kind of annoying. But the reason is we didn't add the function to main. So main doesn't know anything about it. So it's just more proof that magic doesn't apply here. So we'll give it some sort of class of container so it renders in the nice bootstrappy way. And we're telling it here that we want it to render the input view and the issues view. And you jump back over to the browser. Loads up just as you expect. So we're going to go another level deeper here. We're just going to make the labels their own views because they have like some complex data, and technically it's a list of issue or a list of labels. So we can come in here, chunk out this code, and we'll call it label view. So now this holds a list of label views. So if we give it the new DOM chunk down here, we can just reuse this by name now. Everything's still static, like the background color is fixed here, the name of it is fixed to bug. We can update all this in a little bit. And it looks just like it did before. So all the views are converted, but they don't do anything. So we need a way to model our data. And this is like the things that you'd use, just a standard JSON data structure, or maybe you want to use Redux if you're using React. In Angular, you used to put them in resources and stuff. I have no idea what they are now. Angular 2 guy sitting beside me is shooting this at me.
I used it on one experiment.
So the things that we need to model is that our repository has a name that needs to be searched with and a list of issues to display. Elm has this concept called a type alias, and it creates a domain-specific type for you, and it's composable of other types. So pretty much all you're saying is alias this structure, whatever it is, whatever I tell you it is, and give it this name. And pretty much its sole purpose is to keep type signatures clean. So you don't have a bunch of notation that looks like JSON all over your file. So in this case, we're going to name it model. So you say type alias model is equal to, then you use curly braces. We'll explain these in a minute, but pretty much all it means is I'm opening something that would be equivalent to a JavaScript object. They're called records in here. They're completely immutable. You can never change them, but there's ways to get a new version of it. So anyway, we're saying that the value or the key repo is going to be a string. The key issues is going to be a list of GitHub issue, which we don't have yet. And that's it. Is there anything confusing about this? I know it's like the syntax is hard to get past sometimes. So if you do have a question, just please stop me right away and I'll address it. So earlier, if you recall, these are the things that we want to show from a GitHub issue. So we can pretty much just model it directly as is. I want a title that's a string, a body that's a string, same for the URL. The comments, we're just returning the comment count, which maybe I could have named that better, but we're returning an integer. And then we're returning a list of GitHub labels. So if we define a GitHub label, that includes a string that's the title, a string that's a color, and that's it. And that looks like this in the code. I find that super readable to look at when I'm trying to figure out what the type is. The nesting, like when you're reading it, it's a flat structure, right? But you can see that, okay, I have a GitHub issue that has multiple GitHub labels. Well, what's a GitHub label? You jump up to the line above. Oh, okay, it's this thing. And you declare them in the order that, what's a good way to say it? So if you're going to use a type below, you need to declare it above. Just like if you're going to try to use a variable in your code, you wouldn't declare it at the bottom of your function. You declare it at the top. So we need a way to create our initial data. Well, as far as Elm's concerned, this data structure here is equivalent to a GitHub issue because it matches that structure that we saw before. So we're given title, the value, it doesn't work. We're given the body there, and I'm not going to read through all these, but the initial model here mimics exactly what we saw. It's a repo with a string and a list of test issues, which are a GitHub issue. And then labels is a list of the GitHub label structure. So in here, we need to change it a little bit. We're going to say that input view takes a string and returns the HTML. We give it the value name repo string, and we're going to set that inside the HTML. So the compiler here is giving us a warning that we needed to put it up here at the top because we're using input view as a value. We weren't passing anything to it. But below, we told it that input view accepts a string now. So the compiler immediately tells you, hey, you're forgetting something at this line. You need to put it in. So we give it the initial model.repo value, and it's happy. Come on, Keynote. So then the issues view, we know it's going to need a list of issues. We'll just go ahead and pass it in now. And it says issues view is not a function, but you're giving it an argument. So we just have to run through and update it. And that's the really nice thing about having a compiler like this, where if you need to do a refactoring, as soon as you start changing something, it pretty much takes you by the nose and pulls you through the code until you fix all the bugs. So one way to think of it is you don't have to think as hard for where you might make a mistake. Where, I know if you refactor something in JavaScript, you're pretty much guessing, have I grabbed this in all places? Some of the IDEs like WebStorm might be able to tell you most references, but it's still going to mess it. Like it's going to miss an instance if you've done something a little too clever. Like maybe use instead of object.keyname, you did object bracket and pass in a variable. It's going to miss that sort of thing. So in this, we're just saying, I want you to render the issue view in here. I'm going to pass you the issues. Oh, Christ. There it goes. So we have a list containing n number of issues and an HTML element that takes a list of child elements. So what we want is a list of issue view. And we looked at this earlier with mapping. So instead of having to like draw this out in some manual way, we can just say the second argument here is still going to be a list. So I'm going to wrap it in parentheses so it returns this value. And I'm going to say map over the issues and pass in issue view as the function to map over it with. So in here, it gives us this little warning. It says the first argument to function map is causing a mismatch. And that should be like the first indicator, like, okay, I need to change something. I thought this was a function. And it's saying that it's expecting the argument to be a virtual DOM node, but it's HTML. So it thinks it needs one more argument. Oh, sorry, I actually read this wrong. Where it says A, so you pass in something that is of any type. If you see a lowercase variable in Node is in part of the type signature, it can be any type. So it's expecting an A2 node message transformation here, but it's just an HTML message thing. Horribly explained, sorry about that. So look at this again, there's that type mismatch. Can anybody see what's wrong between this line here, where I'm passing in this function issue view, and the declaration of issue view here? Right. Yep, that's exactly it. It's all just, it's function turtles all the way down. So just go in, we say I want you to take a GitHub issue, and the compiler's happy. Yes?
So when we're looking at that div class with row, list map in parentheses, is that just, you said that's a function call?
Yeah.
Returning the value as a parameter to that division?
So everything inside of these parentheses, you can consider this just like math, where everything inside of this is isolated. So you're saying do everything inside of the parentheses first.
Okay.
And then that return value gets returned as a list, and that's what the second argument to the div function is expecting.
Okay.
So you're saying perform this operation first and return it, and that's what I want is this argument here.
So the issue view and issues are just arguments to map.
Right.
Okay.
Exactly.
Can you use those parentheses pretty freely, or does it bitch when you try to like get clever and nest a bunch of them or whatever?
No, it's completely fine with you nesting the parentheses as long as you don't try to use them like you would in JavaScript. So yeah, it has to wrap around. It's more like Lisp in the idea of how you use it, where the parentheses go around the outside, not like list.map paren arguments.
Right.
You just always have to put it on the other side of that. Because it has to be isolating that expression, and then it returns that expression. So we already ran through this, so we'll skip that. So we're going to render the issue data. So the only thing you need to do here is come through and replace all these. So issue.url, issue.body. And you can see it trying to help me as it goes along there. The autocomplete's filling in. So nothing too complex. And this part's important here. Text requires that you pass it a string. So this toString function will help you out and just convert anything you pass to it into a string within reason. And this is another good example of where the parens come in. You just keep throwing them in there. There are syntax like sugar things that you can pass in, so you don't need the parens everywhere too. You can pass in arrows, and we can work with that. So here we're replacing the GitHub labels with the exact same concept. Say I want to map over label view, pass in the different labels. Compiler throws up a warning again, so we just correct it and say like, okay, you're right, I'm going to pass in something to you. So there's the label. And now we can replace the sketchiness I had with an actual value. And label.title is already a string, so we don't have to tell this one to convert to a string. Why is it doing this twice? Anyway. Come on. Oh my God. There we go. So everything works. So now we have to add some behavior to the application. Because again, I'm just rendering things out. I'm not actually saying like, hey, I'll handle that click for you. I will happily accept that you text things into the, enter things into the text box. It's just kind of sitting there. So this is where that thing I mentioned earlier, a program, comes into play. So HTML just has this function on it, and it knows how to set up data like this. HTML.program expects you to pass in a record that is shaped with an init function. It's pretty much just a tuple. It wants you to pass in something with a model, which is like our data structure model, and this thing called a command message. You can completely ignore this for a little bit. The view function expects you to pass in a model and return HTML. The update function takes a message of some type. It takes a model, and then it will return a model and a command message. Subscriptions, ignore this entirely. This is irrelevant for this presentation. So in here, we're going to pass in this update function. I've just gone ahead and we've made these values, right? So we're making a init here. A init is a value of a model on a tuple. So we're going to give it initial model, the thing that we declared earlier, and command.none. That's the only thing you have to pay attention to. We're saying Elm runtime, I don't need to do anything special here. So here's no value. That's effectively all that says. And then you can see subscriptions is taking a lambda and doing this pretty much the same thing. Update, we have to pass it some sort of message and model. And for right now, we're just going to keep calling the init function because it's expecting you to return that type signature. An object, or I shouldn't call it an object. It's expecting you to return a tuple of a model and a command message, and we're doing that here. So as far as this function is concerned, we're satisfying it. It just doesn't do anything interesting. Okay, so in our main, I'm just going to rename this to view because it's pretty much the same function. It just needs to accept the model now. And now we call model.repo versus initial model. So this is where it says main no longer has a thing, whatnot, annotation. So we can just copy it in, and we don't really need to care about what it is right now. We're just satisfying it so that that bar doesn't pop up at the bottom and annoy us during the presentation. So what can our app do? It can set a repository name, and it can fetch issues. So we pretty much need a type here. We need something to say, these are the two things that our application is capable of doing. It's pretty much a way to say, like, I have this complex data that I need to represent, or a list of things that I can accept in my function. So in PHP or Java or C++, you have interfaces. This is kind of a similar concept where you can say if any of these types satisfy this interface. In this case, we're saying any of these types are safe to pass into this function, even if they are completely orthogonal and relate nothing to each other. As long as they come into here, they mean something to the application. The example from the Elm documentation shows a way to represent a user. A user could be anonymous, or they could be a named user with a string passed in that represents their name. So a list of active users here, if we have like a chat application, there could be one anonymous user and I could be sitting in the room. I guess one thing to point out, and I can't remember if I do it later in the talk, but I have that concept named string. Named is a constructor function. So think of it like in JavaScript, you can return anything from a function. If you have named and I pass in a string, I've now returned that type of an object, a named Machuga, sort of thing. I apologize. I haven't given this talk in like 3 months, so I've forgotten my flow of things. So we're going to declare a message type for our application. We're going to say that a message is a set repo operation that accepts a string, or it's a fetch issues operation. Those are the two things that our application is allowed to do. It just looks like that. And this sort of concept is done for determinism. We can tell everything that our Elm application can do when it's compiled. So that way you don't have things sitting out there like switch statements, which might have a default clause, they might not have a default clause, or you can pass in any variable type to a function and anything could happen. Elm wants to be sure the things that are occurring are the things you intend to be happening. And this is done in pattern matching. So it's pretty much like a switch statement, but awesome. And it looks something like this. So message is passed in. We're going to uppercase it to the type message because now it's declared. It's not like any random type anymore. It's this thing. And we're going to say that the case of message, you can kind of read like in the case that message is a set repo with a string repo, I want you to perform anything where those dots are. So in this case, the arrow is representing like, you can consider it like a function block or an execution block. So in here, I replaced the update function with this new code. And for people on the internet, I'm using a laser pointer, so I'm sorry. So I've added this in here, and now I'm returning this model and a command none. So pretty much just returning the same thing over and over again. And the compiler down here is unhappy with this. It's saying your definition of main doesn't match anymore. And that's where I've changed it in the update function to expect a message. And it still thinks it's looking for any type. And it's saying it cannot be anything, even though you're trying to tell me that it can. And it even gives you this nice little link down here, which explains everything to you. So that's pretty fantastic. So all we have to do is update the type signature. And now it says you need to account for the following values. That's down here. It says the fetch issues. So our type was message, and type can be one of those two things I mentioned before, set repo or fetch issues. And we have to cover this pattern or it's not going to accept it. So once we add it in there, it happily lets the program compile and it's good to go. So we update a record. Remember, we're not actually updating a record. We're returning a new copy of the record with a certain value changed. So it's like just reassigning something. And the easiest way to read this was described to me by a coworker I had a couple months ago even. He said you should read this as you're getting a model such that key is equal to value. So that's like the one difference in this version of it. So if I set a repo name, I'm getting the model such that the repo key is being set to the value repo. And in order to see what's happening here, I'm going to load in this debug view. And because Elm doesn't really let you have side effects, like I mentioned earlier, this is just a way to convince the runtime to do something for you. So I'm going to get this little pre-block in here. Oh, I'm sorry. This isn't the same debug view. This one is just so we can see what's happening. I'm going to output a textual representation of the model, which is pretty much going to be JSON. So all this is in there, but it still needs to be wired up. None of the buttons know they're supposed to be doing things. None of the text input doesn't know it's supposed to respond to events. So we need to start adding these. And to do that, we'll import HTML events. And we're going to grab the onClick, onInput, and onSubmit events. So I'm exposing these as unqualified imports, but I'm not taking everything out of that module. Again, that's all it means. Because I'm not going to use everything. I just need these three things. So for the text input, we're going to say when a key is typed, pretty much, on inputs like any sort of input detection as far as JavaScript is concerned. On input, I want you to send it this message, and it will pass over the value for you. But then we get this warning down here where it says, you're expecting HTML with the lowercase message, so it's HTML with anything, but you want a specific result. That's what set repo is expecting. So we run a little update on it. So this Keynote responds. Update it. And now it's saying that view doesn't match the type annotation. So we update that, and it's happy. Again, it just like took us by the nose and pulled us through and said, fix these things and I'll run for you. So now if we load up the browser view, wow, that was like a 10-second lag. Updates in real time for you. So it does the thing. And now we just need to hook up the other events. So on submission of the form, we're going to say fetch these issues. And for the purposes of this demonstration, because it's going long, I'm not going to actually show you how to do the HTTP AJAX calls and update things, but you know, just consider that this is fantastically awesome and does things. So we have this idea in JavaScript, in C++, and pretty much most languages where there's this idea of null. And null is just something that doesn't exist. And the person who created null as a value calls it his $1 billion mistake because he estimates that he's cost at least $1 billion in damage by doing so. So you can go ahead and boo me for the call me maybe joke. Elm, since it doesn't have null, you have to say that you're representing a concept of nothing in some form. So there's this type called a maybe. And this says the value is either just a string or it is nothing. And the developer has to account for both. There's no forgetting to handle a null object being passed in and then calling a method on it and having your program explode. It says you need to deal with this or you're not allowed to use it. So in model, we're going to add a property named alert here. And this is just some way to provide feedback to the user. And this is possibly going to be a string. In the initial model, we're going to start off with nothing. I don't know why it's running twice. Okay, and then we're going to make everything a little bit more real. So when the application boots up, the initial model is now going to be blank. There's going to be no issues. Okay, so when we set the repository name, we now need to explicitly set alert to nothing in the event that there's, let's say I've already entered something that's an invalid repository name and I get that alert. If I start hitting backspace, I want that alert to go away because it knows I'm trying to fix the problem. So I'll just set the alert to nothing. And then this is where some sketchy fake magic happens here. So if the model repo is equal to that specific repository name, I want to load the test issue up into memory. Otherwise, I just want it to return, this doesn't exist, set the alert to try another repo, and return an empty list. And again, this is just get around not making HTTP calls. So to update the views, all we really had to do was tell the view function, the top level view function, that we now have this alert view concept. And the alert view is defined down here as taking maybe a string. And in the case that it does have an alert, it's going to return this div element. And otherwise, it's going to return nothing. If you return an empty text node, that shows up as a blank element in HTML. So this is a great way to implement potential, like a DOM element that you may or may not want loaded onto the screen. So we're going to watch this run real quick. If I type in Elm and press enter, it shows that error message. As soon as I started backspacing, it got rid of the alert. And once I typed in the real repository name that it wants, it properly loads up the issue at the bottom there, and then it shows us all the debug information. So the base of this is pretty much check out Elm. And honestly, I don't even want you to just, hey, go learn Elm because it's the greatest thing on earth. It's pretty cool, but the more important thing is the concepts that you get out of it. I know before I started checking out Haskell and other languages that support maybe, I was pretty unsure of like what the big benefit was there. I would hear it on podcasts that like, this maybe type's the greatest thing on earth. And I kept listening to it like, I still have to do all the work. I still have to do a null check. So what's so awesome about it? And it pretty much comes down to the fact that you have a compiler that says, you missed this, go fill in the blank. And you don't have to care about whether that value is actually there until you go to use the value. So like Swift Lang uses a lot of this concept now where you can pass optionals around. And when you need to use it, you just unwrap it from its little protective box, the maybe, and you can use the string value. Different concepts like that, or just like the simplicity of functions. Those are the things that I got out of learning Elm and learning a little bit of Haskell. If Elm doesn't suit what you're looking for, there's TypeScript. There's TypeScript and the flow type checker. They both support type unions, the type alias concept. There's also PureScript, which is more of a Haskell in the browser. It supports more of Haskell syntax. I think it's harder to learn at first. There's a lot of powerful concepts in it, but again, Elm's like Haskell on easy mode. So if you just want to get a feel of these concepts, I recommend taking a look at this. So these are some of the resources that you can use. The Pragmatic Studio made some great courses on it. They're super affordable. I would recommend checking those out. There's a course on KnowThen that's completely free, and that one's fantastic. And then Daily Drip also has a series of videos available. So again, like I guess I should since it's on the internet. I'm Matt Machuga. You know that already. I run this site. It's called Bits and Trees, where I try to teach computer science theory to web developers, along with different concepts. I try to explain things like promises, JavaScript asynchrony, things like that. So this is our little representation that I had to do in Texas, of course. I had to throw something there. And then one final mullet. So that's all I got. Technically. So yes, thank you. So if anybody has any questions or wants to see functional Elm code, I do have some loaded, or we can just go to like the help portion of the thing, or we can just hang out and talk. Either one. I think I'm just going to shut off the live feed. So thank you, internet. As soon as I figure out how to deactivate it, I will.
How would you say that using Elm and Haskell and other functional languages has changed the way you approach and write in PHP?
It's hard to say with PHP because there's those extra concerns that you have to keep in mind where, can somebody grab the lights? Thank you. Where in PHP, you have to keep concerns in mind. So you don't want to allocate something too many times. So certain languages can optimize this sort of thing, where if I iterate, if it looks like I'm calling list.map, 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 and I'm doing all these actions, it'll actually just like take a look at the program and go, yeah, you're not doing anything destructive, and smash them all together into one call. Because there's like algebraic rules that are in play there and you can use them. In PHP, it's more like, oh shit, you are thrashing the garbage collector. You're wasting all sorts of memory. Oh, I'm still broadcasting. Bye.